In this demo, we use the new and improved features in Sketch and Sketch to construct a program that outputs a von Koch snowflake fractal. Although during the demo we could perform normal text editing of the program at any time, we will use only output-directed interactions to make the design. To construct our first helper function, we place points on the canvas in roughly the appropriate locations. Even though these points are not yet used in the program's final output, number-number pairs encountered during execution appear as point widgets on the canvas. The relate tool searches for an arithmetic term to define one of the points in terms of the others. The guess and check process of this tool takes about 20 seconds here. With one point constrained to be 1/3 of the way between the other two, we abstract this expression into a function and rename it appropriately. With new example points, we construct our second helper. Using the new distance features, we select the distances between the points and use the make equal tool to ask a computer algebra system how to enforce the equality. As before, we abstract the expression into an appropriately named function. Type inference notices that our functions take 2 points as input, so the functions are offered as drawing tools. With these two helpers and the new snap drawing interaction, we construct the skeleton of one side of the snowflake. As before, we abstract a new function and rename it. To make the recursive calls, we focus the function and, after renaming the arguments, draw the function inside of itself. Only the blue point is in the output of the function. To get the white intermediate points in the output, we focus a base case of the function and, after fumbling around a bit, add those intermediate points to the output. To make sure the final polygon will be drawn correctly, we reorder the points, checking their order by seeing which expression is highlighted in the program for each one. We update the output of the recursive case similarly, using list widgets to select the points returned by the calls to the base case. The lists are added to the output in the order we selected them. We choose a termination condition. Only fixed depth termination is automatically supplied for now. Back at the top level of the program, we reuse our equitripoint helper to lay out a skeleton triangle. We attach our fractal points to each side, and after renaming for clarity, we use the group tool to flatten the 3-point lists into one list of points. We also rename the flattened list, and then use the make equal tool to ensure that each of the 3 sides of the snowflake recurses to the same depth. So far in the design, we have only modified intermediate values in our program. At the end of the program, notice how the final shape list is still empty. We are now ready to actually add something to our program's final output. We attach a polygon to our snowflake points. After a few final design tweaks to the color and to the position of our snowflake, we increase the recursive depth to 3, and, after waiting a moment for all the widgets to process, we hide the widgets and view our final design.